All right, so this is lesson 17, a very simple concept, I believe. I think everyone kind of understands these non-parametric versions of what we've already done, especially when we've done it in the parametric world. So real quick, let's just remember what we did in the previous two lessons, if you will. So we had this thing called LDA and QDA, where L stands for linear discriminant analysis, and the Q one was the quadratic discriminant analysis. And there was a small assumption that made the difference between these two, but just understand there's just two different techniques, and they sort of do the same thing, as far as classification goes, and they have the same assumptions with them that this X vector or this X random vector is distributed as a multivariate normal distribution, where you have a vector mu j. I'm sorry. So one thing I want to point out is I changed the variable from k before, and the reason why I did it is because it's this k nearest neighbors. I don't want to change this k, so I had to change this one in order to. So this is just represents the class that we're talking about. So it's just some arbitrary class. So the probability that the observation is in class J, given that x is equal to x, and this is the new thing, this little thing this x value is what we're trying to classify, but we're assuming that it's coming from the multivariate normal distribution x, right? It looks sort of like this, where this is a different mu j depending on what class. I mean, mu would be different depending on what class we're talking about, and the covariance matrix will also be different depending on what class we're talking about. And we estimate it using the data. So that was before. So this is called a parametric way of getting at it. Why? Well, because I'm assuming some parametric distribution. I'm assuming some multivariate normal distribution. In the k nearest neighbors, I'm not assuming that. It's sort of very non-parametric. There's no assumption that we have a normal anything. It's just this is the data. And so as you might imagine, we still need to find the same probability. Well, what's the probability that your data is coming from this class, or we're going to classify it as a j, as whatever j is, given that this thing is x. So what I've done is I'm going to set p equals 2. So obviously, p is equal to 2 in this particular case. Why? Because I can't draw anything higher than that. I'm just not that good. So in this case, where I got x1 and x2, I got p equals 2 predictor variables, and I've just sort of arbitrarily thrown some points out there on the board. I gave them numbers, in other words, like this is the 0th data. So this would be 0, and then I could calculate this. I could say, I don't know, that's about 2 would be my x1 value, and then x2 would maybe 1.5 or something. No, I think this would be 2, and this would be 1.5, something like that. It's a little bit bigger. And then we would do the same thing for our, and then it's because it's blue, it would be classified as a 0. So that would be 0. So my next set of data would be this one, and you have the same x value. So 1, 1.5, and then maybe it goes up to 3.5. Again, I'm not trying to be very specific here. I'm just kind of showing you that this data would be in the data frame, or table, Excel, CSV file. It would look something like this, right? And it would go all the way out to, I think we got nine pieces of data, and this 9th one is classified as a 0 as well. The 8th one is classified as a 1, and so on and so forth, right? So we could literally go through it, but that's not the point of this. The point of this is to figure out, well, how would I classify that guy if I'm going to say I only want the first nearest neighbor. What is the first nearest neighbor? Well, it looks like to me that 4 is the nearest one, so I would classify this one as whatever 4 is. Well, you could look in the table, or you could just read it off here. Because it's red, it must be a 1. So there you go. So I would classify, if I was doing the 1 nearest neighbor, it would be a 1. And then maybe, so I'm going to put a little 1 here, so meaning that's the closest. And maybe, I can't really tell, but maybe this guy is the second closest, and maybe this one's the third closest. So if I was using k equals 3, then I would do the same thing, right? I would just find the indices. Actually, we'll talk about that in a second, about being the indices. We just find the 3 points that were the closest to x, and then we just count up the number of blue ones and the number of red ones, and we would pick the one that had the highest number. So in this case, if it used k equals 3, then I would obviously classify this as a 0, because I have two of those that are closer, are in that set of points that are closest to the x value that we're trying to classify. Okay, so let's go down and just make sure that we understand the math equation that's written here, right? So that's all I'm doing now is, let me erase this. Yeah, that's right. Okay. So what is k equals, when k is equal to 1, what is the index? So these are indices that go in here. Indices that go inside new knot, and this, or end knot if you want to call it end knot. But in this case, it would be 4. So I would put the index 4 in there, and that 4 represents the one that had the index of the data point that we're talking about, right? So the 4 would have a 1 on it, and then let's see over here to 1. So if I was doing k equals 2, I would have a 4 and a 1 in here, where 1 represented a 0 and 4 represented the 1. And so how would I classify that one? If there's a tie, obviously you would look at and see which one was the closest, right? So there's got to be a tiebreaker if you have, if you're doing this discrete sort of adding up. And then the next one would be, say 4, 1, and 2. So 4, 1, and 2, right? So let's just go ahead and choose this guy right here, this green one. I'm gonna choose k is equal to 3 because it'll give us something to work with down here on this equation. Okay, so k is equal to 3. My end knot, or my new knot, is 4, 1, and 2. So those are the indices for the data points that are the closest to the thing that I'm trying to classify. And so now if I want to calculate this probability, well, I know it's going to be 1 over, so it's going to be k. So 1 over, let's do this. Let's say for class 0. Here, matter of fact, let me just do this in blue. Maybe that'll help make more sense. So I'm going to do this in blue. I'm going to say 1 over 3 because I chose k is equal to 3. And then I'm going to sum up. So this first one is, well, I is in new. So I'm going to go over here and I'm going to have 4. So the first one is 4. So I is equal to 4. And so y4. So y4 is 1. Does 1 equal 0, right? Because I'm doing j equals 0 for this one. So 1/3, does 1 equal 0? No. So this is called an indicator function, and if this is not true, then you get a 0 out of it. So 0 plus, and the next one would be 1. So you go into 1. So I is equal to 1. So y1, go up to y1, and you would get 0. So y1 would be 0. So 0 equals 0. Yes. So because it's an indicator function, I add 1 to it, right? And I go back and I do the next I is equal to 2. So if we did 2 would also be equal to 0. So the answer would be, these two would be equal, and we'd have a 1. So this would be 2/3. All right, and then I would go to my class, my next class, j equals 1. And again, it would be 1/3, right? So this isn't going to change the ordering of these, but I would come back in and I'd do the same thing. We'll put 4 in, y4, we would get 1. Does 1 equal 1? Absolutely. And we get 0 in the other ones. Okay. So these probabilities work out so that, that you would choose the one that is the largest, right? So I would choose j to classify this thing as whatever these blue ones are, right? So these are all class 0, so that's how I would classify this one. Okay, and that's basically how the formula works. Now understand that this 1 over 3, 1 over 3, it would be on every single one, or whatever k is, it would be on every single one of my classes. So technically, if you just find the number that's in each one of them, then you'd be fine. Okay, so now I'm going to walk through the Jupyter Notebook. So if you didn't go to the Jupyter Notebook, you can open that sucker up. And you can see the same probability statement here. Again, it's a non-parametric, so all you're doing is sort of adding things up. And then you come over here, and let's go Shift Enter. Might take a second to connect. So all I did here is I'm trying to reproduce figure 2.14 in the book, and I just went inside that figure, and I looked at the x and y values, and I gave it, I think the blue ones were 0 and the orange ones were 1. You can go in there and check it out yourself. And then this is just going to plot them out. And so you can see that, yeah, these blue ones are 0. So this is the index that goes along with it. So 0, 1, 2, 3, 4, 5. You can see. So if I'm trying to classify this red one, you can see that 2, 3, and 4, and I'm using k is equal to 3, which I'm going to do here in a second, then I better get 2, 3, and 4 in my new knot, right? So or my N0. This uses broadcasting in order to take that point, that red point, and then find the distance between that point and all the square distances between that point and all the other ones. And as you can see, those three here are the ones that are smallest. And so that represents 0, 1, 2, 3, and 4. So we think we're going to get it right. And now the next step is to find the data with the k smallest distances. And so this code in here just says k is equal to 3. You know, Pat, do arg sort and then only find the first k of them. And if you do all that, you'll find that 3, 2, and 4 are in fact the ones that are in the in there. And it's 3 first because it's the smallest, and then 2, and then 4. And then so this last one, neighbors, it says that I have 1, a 0, and a 0, right? So in other words, it's neighbors. This is the classification of each one of its neighbors. So I have a 1 and 2 zeros. So I think we should classify this as a 0, but how are we going to do that? Well, go back to the data, get all the unique numbers, and then basically go through each one of the unique numbers and add the number that's in this neighbors, right? So I find out that I have 2 zeros and 1 1, so therefore we do argmax of that thing, and you come out with 0. So let me make sure I hit the button on each one of these so that we can use it later on. And then the final thing that I want to do in this thing is to create a function. I'm going to call it k and n. Just note some of the things in here. You give me k, the number of points we're going to use to classify. Make sure that your data, so this is pretty important. Make sure that your data's last column is the one that has the classifier on. Don't put it in the first column or in the middle somewhere. It needs to be at the end for this thing to work anyway. And then you can see I got -1 there and -1 there to go to the end to do all the class stuff. So if I hit Shift Enter here, hopefully I get 1 out because 3, 5. So if I go back up here, 3, 5 should be right there, and I have 3 1s sitting in there, and that makes sense. Okay, so I'm recreating the picture in the book. So this was the picture. I'm just going to show you that you're actually doing something when you're pressing the button here. So I'm going to change it. Instead of yellow, I'm going to do orange. And you can see that it can go to the book, check out what this thing's doing. So this is doing some kind of mesh grid. And so what does mesh grid do for us? Well, I can let x1 go from 0 to 5, x2 go from 0 to 6, and then I'm going to mesh those grids together, and I'm going to produce these things that I can now use in order to use that k and n thing that I just created. Pass in k, pass in the data, and pass in the value, the thing that I'm trying to classify, which is just right above it, which is your x1 and x2, and then find the integer value of it. And then the last thing you do is all I really care about for that particular point, x1 and x2 point, is what color it is, right? So that's all I'm doing. So I'm passing back out either a blue or an orange, depending on how it's classified. So if it's classified as 0, I'm pulling out a blue. If it's classified as a 1, I'm pulling out an orange. And then we're just plotting it, right? So that's all we're doing here. The next part is, hey, I'm going to use Scikit-Learn to do the exact same thing. So Shift Enter. So Scikit-Learn is going to, so I'm just bringing out the data, bringing out y, and then I'm using the fit function. And now I'm just testing it and make sure it's going to work. So 2.14 we know was a 0 before. And now knn.predict. So instead of knn, that function that we created, I'm just passing in just the x in the format that it wants so that it can classify it. I can integerize it again and then pass out the color. So let's make sure that this gives us exactly the same thing we did before. It's like it takes longer than my function that I created. So, all right. And then just to show you that you're doing something different, orange, what goes with blue, maybe purple. Let's go orange and purple. And eventually we get something that looks like that. Okay, so you can see kind of what's going on, that this is the inner workings of what's going on in the Scikit-Learn's version, and then here you're just using it, right? So this is what we've been doing. You know, after we learn the mathematics, after we learn all that, then we kind of pass it and then start using Scikit-Learn's whatever classifier that they have, or whatever classifier we're talking about. Okay, so the last thing I want to do is just show you some things that we do in to use this sort of classifier and to talk about a couple other things. Like we're gonna do something new today. We're gonna do this classification report. We're gonna do the plot matrix thing, I believe. Okay, so let me pull in the Titanic data. We've seen this before. Let me fill in the age. I don't know if I didn't do .info, but if I did .info, you would see that age has some missing parts. We did that the other day. We see age is no longer missing parts. I just filled in with the median. All the NAs I filled in with the median. Let's get the columns. So there are the columns, and you can see I just copy pasted those columns into here, and I got rid of alive. So I got rid of that one, and I got rid of survive. So shift enter. And now I'm going to find out what's the best one of these hyperparameters to use. So as you can see, we in here, we got the X's, got the dummy variables, survive is the response variable. We did X train, X test, Y train, Y test with the TST. And then we came down and said, all right, well, let me train this. In other words, what's the best K value that I can use? So again, we're using the train set, and then we're trying to predict using the test set. So I don't think we're over fitting this model. And you can see that maybe 5, 6, 7, somewhere in there probably works pretty good. And then I think I just picked 4. I don't know why. I should probably pick 7. Shift enter, and you can see the confusion matrix. So you get 0.73. So remember what the confusion matrix is. This is the actuals on the, well, whatever you pass in, right? So we passed in the actuals on the row, and the column contains the predicted. So if this were actually 0, meaning the person died, then I predicted 132 of those would die, and then 28 I predicted of the guys that actually died would live, and the other way around, the people who lived, I predicted 44 of those would die and 64 would live. So these, obviously the diagonals are the ones that are the good ones. So if you added this divided by the total number, you get 0.73. So now I want to talk about or I want to at least show you with the classification report. So pass in the same 2 pieces of data. And it's not very sexy right now because it only has, 2 classes. But once we get more classes, what we're talking about here in a second, this will maybe provide you a little bit more information. So, all right, that's that. And now let's roll to train. I'm sorry, to train and test of the Miniset data. So actually, I don't want to do this. You guys can go back and do this. I'm going to do the fashion data. And I'm not sure if you remember, but the fashion data looks a lot like, it has 10 classes of shirts, boots, pants, t-shirt. I mean, that has a whole bunch of different pictures of different things in there, and then we're trying to classify them. Okay, so all this does shows me that I got 60,000 tests and 60,000, or sorry, 10,000 train. I'm sorry, 6,000 train and 10,000 tests. So now let's create a nearest neighbor. I'm going to use 5. I should probably use. Yeah, we'll use 5. Let's use 5. And then I'm using this KNN. So I used to write all this in one little setting, but the problem was this thing takes a while to do. So let's find out how long it takes. And this is the reason why I'm using, I generally do it on my computer, but I found out that CodeCalc is much, much quicker. It has more processors, and it's doing more things in here for you. I do both of these when we're done. The problem with the confusion, plot in the confusion matrix is that it reruns the model. I have no idea why, but it just reruns the model. I mean, as you can see, the input to this thing is the model that we created, right? So KNN, and then the X test and the Y test. I mean, it's funny that that's how they go about doing it. And all they're doing is just plotting the stuff that we already have. Okay, this is the stuff we already have, and we'll see what it's doing. But look, we're getting an 85.9% accuracy, as opposed to, I think LDA was the best the other day, and it was in the 82s. So now let's do this, and you're going to see that it's going to take a while to do the matrix, right? So what it's done right here is it's printing out the different classes, the precision associated with those classes, the recall, the F1 score. Again, go to Scikit-Learn's page and make sure that you understand kind of what's happening out here. This 1,000 just means it has 1,000 zeros. Supports just means the number of zeros and number of ones and so on and so forth that it has. But in order to do this confusion matrix, it's just redoing the entire, it's doing everything again for you. So hopefully it's going to come out and it's going to have the same picture that we had here, probably, but we'll see. And there it is. So 874. So it's just got that number right there, and then it's got the 1 and the 16 and the 11 and the 5 and then the 86. You can kind of see what's going on there. Again, what I don't understand is why Scikit-Learn thought it was okay to redo this. Maybe there's a better way of doing it than this. Maybe you can just pass in the model already done. Not sure, but that's what you get, right? So I don't know. I think this is a little bit prettier, and it's kind of showing you some of the issues that you might have. Like obviously 6 is struggling compared to maybe some of the other ones. Let's see, what did it say? Yeah, it says 6 is hurting. So you can see 6 only has a 0.68% or 0.68 precision, as opposed to maybe 1 is a lot better. Yeah, it looks like 1 is a lot better. Okay, well that's all I got for this class. Hopefully you guys got something out of it, and we will see you next time.